Now, number one, complete the table below. The binary operation P asterisk Q. The binary operation is defined by P asterisk Q is equal to P squared plus 2PQ minus Q squared. That means, and it's defined on this set. The elements of this set, these are the elements of the set T. So that means minus 2 asterisk minus 2 will be equal to minus 2 asterisk minus 2. Here, this is P and this is Q. So that will be equal to P squared, which will be the square of this minus 2. Minus 2 squared plus 2PQ. That's 2 into bracket minus 2 times minus 2 minus Q squared minus the square of minus 2. And that's equal to 4 minus 2 times minus 2 is 4 times 2, that's 8. 4 plus 8 minus the square of minus 2 is 4. And this simply means 4 plus 8 is 12. 12 minus 4 is 8. So that means this is 8. Now to the next one, minus 2 asterisk 1. Minus 2 asterisk 1. Let's find that. Minus 2 asterisk 1. Minus 2 asterisk 1 will be equal to minus 2 square, that's P square, plus 2PQ plus 2 into bracket minus 2 times 1 minus Q square, that's minus 1 square. This is P and this is Q, and that's equal to 4 minus 2 times 1 is minus 2 times 2, that's minus 4. 4 minus 4 minus 1, and that's equal to minus 1. So this will be minus 1. That means minus 2 asterisk 1 is minus 1. Now to the next one. What is minus 1 asterisk minus 2? Minus 1 asterisk minus 2. Minus 1 asterisk minus 2. Minus 1 minus 1 asterisk minus 2 is equal to P squared plus 2PQ. That means plus 2 into bracket minus 1 times minus 2 minus Q squared. That's minus the square of minus 2. And that's equal to 1. Minus 1 times minus 2 is plus 2 times 2. That's 4 minus the square of minus 2 is 4. And that simply means 1 plus 4, 5. 5 minus 4, 1. So minus 2 minus 1 asterisk minus 1 asterisk minus 2 is equal to, what did I get? Is equal to 1. Minus 1 asterisk minus 2 is equal to 1. Now to the next one. We go to the next one quickly. That's minus 1 asterisk 2. Minus 1 asterisk 2 is what? Minus 1 asterisk 2 is equal to P squared, that's the square of minus 1 plus 2PQ plus 2 times minus 1 times 2 minus Q squared. That's minus the square of 2, and that will be 1. Minus 1 times 2 is minus 2 times 2, that's minus 4 minus 4. And that will be 1 minus 4 is minus 3. Minus 3 minus 4 is minus 7. So minus 1 asterisk minus 1 asterisk 2 is equal to minus 7. Is equal to minus 7. Now to the next one, which is 1 asterisk 1 asterisk minus 1. What is 1 asterisk minus 1? 1 asterisk minus 1 is equal to 1 square plus 2 times 1 times minus 1 minus the square of minus 1. And that's equal to 1 minus 2 minus 1, which is equal to 1 minus 2 is minus 1. Minus 1 minus 1 is minus 2. That's minus 2. And that means 1 asterisk minus 1 is equal to minus 2. The next one is 1 asterisk 1. What do we get when we do that? 1 asterisk 1. 1 asterisk 1 is equal to p square, which means 1 square. This is p and this is q. 1 square plus 2pq, that's plus 2 times 1 times 1 minus q square. And that simply means 1 plus 2 minus 1. 1 plus 2 is 3. 3 minus 1 is 2. And that is 2. That means 1 asterisk 1. 1 asterisk 1 is 2. 1 asterisk 1 is 2. Now the next one is 2 asterisk minus 2. 2 asterisk minus 2. 2 asterisk minus 2 will be equal to 2 square plus 2 times minus 2. That's 2pq minus q square, which is equal to 4 plus, no, 2 times minus 2 is minus 4. Minus 4 times 2 is minus 8. 4 minus 8 minus 4. The square of minus 2 is 4. That will be minus 4. So that 4 minus 8 is minus 4. Minus 4 minus 4 is minus 8. And that means 2 asterisk minus 2 is equal to minus 8. 2 asterisk minus 2. 2 asterisk minus 2 is equal to minus 8. Now the next one is 2 asterisk 1. What's 2 asterisk 1? Let's do that quickly. 2 asterisk 1. 2 asterisk 1 is equal to 2 square plus 2 times 1 minus 1 square. And that's equal to 4 plus 4. 2 times 1 is 2 times 2, that's 4, minus 1. And that's 8 minus 1, which is 7. So 2 asterisk 1 is 7. 2 asterisk 1 is 7. And the next one is 2 asterisk 2. 2 asterisk 2. 2 asterisk 2 is equal to 2 square plus 2 times 2 times 2 minus 2 square, which is equal to 4 plus 8. 2 times 2 is 4 times 2, that's 8 minus 4. And that's equal to 12 minus 4, which is 8. So that means 2 asterisk 2 is equal to 8. 2 asterisk 2 equals 8. Now, and that's the table. We have completed the table. We have completed the table. Now, let's see what's it called. What's the next one? The next one is question B. Let's go to question B. What does that say? We might need to bring the table down. Let's bring the table down. Question B. Let's go to question B first. Question 1B. What's the question? If 1b, using the table in 1a, find the value of p such that minus 2 asterisk p asterisk 2 is equal to minus 7. If minus 2 asterisk p asterisk 2 is equal to minus 7, find the value of p. How do we find p? We have to go to the table. Let's bring the table down. Let's bring the table down. This is the table. Now we have the table here. Minus 2 asterisk p asterisk 2 is equal to minus 7. First of all, this is what we do. We want to find what we need to combine from the table. What do we need to combine with 2 to get minus 7? What do we need to combine with 2 to get minus 7? When we get that, that means that number is the same as minus 2 asterisk p. Minus 2 asterisk p asterisk 2 is equal to minus 7. So we have to check the table to find what we need to combine with 2 to get minus 7. And what's that? Let's go. Minus 2 asterisk minus 2 is 8. That's not minus 7. This is minus 7. So what combination gives us minus 7? That's minus 1 asterisk 2. Let's check that again. This is minus 7. Minus 1 asterisk 2 gives us minus 7. That simply means minus 1 asterisk 2 is equal to minus 7. Minus 1 asterisk 2 is equal to minus 7. And at the same time, minus 2 asterisk p asterisk 2 is equal to minus 7. When you combine minus 1 with 2, you get minus 7. And when you combine minus 2 asterisk p with 2, you get minus 7. That simply means that minus 2 asterisk p is equal to minus 1. So that therefore means that minus 2 asterisk p is equal to minus 1. Now we go to the table again and check what we need to combine with, what we need to combine minus 2 with to get minus 1. So let's go to the table. What do we combine minus 2 with to get minus 1? Let's check the result. Minus 1. This is minus 1. What do we combine with minus 2 to get minus 1? So that's 2 asterisk. Let's see that. What do we combine minus 2 with to get minus 1? What do we combine minus 2 with to get minus 1? So we go to minus 2. Okay, let's check that again. No. We should do that properly. What do we combine minus 2 with to get minus 1? What do we combine minus 2 with to get minus 1? So we go to where we have minus 2. That's it. This is minus 2. So what do we combine it with to get minus 1? And we'll see that minus 2 asterisk 1 will give us minus 1. What we are checking is what we need to combine minus 2 with to get minus 1. So we go to minus 2, which is this. So minus 2 combined with what will give us minus 1. That's minus 2 asterisk 1. That will give us minus 1. So I check that again. What do we combine minus 2 with to get minus 1? So we go to minus 2. What do we combine it with to get this result, minus 1? We'll see that minus 2 asterisk 1 will give us minus 1. So that simply means minus 2 asterisk 1 is minus 1. Minus 2 asterisk 1 minus 2 asterisk 1 is equal to minus 1. That therefore means that P is equal to minus 1. Sorry, that therefore means that P is equal to 1, because P is what you combine with minus 2 to get minus 1. And if you check the table, you'll see that that number that you combine with minus 2 to get minus 1 is 1. That means that P is equal to 1. And that's it, very, very simply. So we go to the next one, which is C, question 1C. Given that px squared plus qx plus r equals 0. Given that px squared plus qx plus r equals 0, use the method of completing the square to show that x equals minus q plus or minus root q squared minus 4pr over 2p. How do we do that? Now let's see. Okay, I need to check this again to be sure. Minus 2 asterisk p asterisk 2 is equal to minus 7. That means, what do we combine with 2 to get minus 7? This is minus 7. What do you combine with 2 to get minus 7? Minus 1 asterisk 2 is equal to minus 7. Oh, that's correct. Minus 1 asterisk 2 is equal to minus 7. And that means minus 2 asterisk p is equal to minus 1. That means minus 2 asterisk p is equal to minus 1. Okay, that's correct. Now, yeah, that's correct. Minus 1 asterisk 2 is equal to minus 7. And we also know that minus 2 asterisk p is equal to minus 2 asterisk p asterisk 2 is equal to minus 7. That simply means minus 2 asterisk p is the same as minus 1. Yes, that's correct. So now let's go to question C. Given that px squared plus qx plus r equals 0, use the method of completing the square to show that x equals minus q plus or minus root q squared minus 4pr over 2p. Now, first of all, this is what we do. We divide through by p, so that the coefficient of x squared will be 1. Dividing through by p. 0 over p is the same as 0, so we don't need to write that. That simply means x squared plus q over px plus r over p equals 0. Now we move the constants to the right hand side, and that means x squared plus q over px equals minus r over p. Now we complete the square for x squared plus q over px. And how do we do that? How do we complete the square for x squared plus q over px? That simply means x plus the coefficient of x is q over p. Half of that is q over 2p. So that will be x plus q over 2p all square over 2p all square minus the square of that half the coefficient of x, which is minus the square of q over 2p equals minus r over p. And now, where do we go from there? That simply means x plus q over 2p, x plus q over 2p all square minus q, the square of q over 2p is q square over 4p square. If you square 2p, that simply means 2p times 2p, and that gives us 4p square. So this denominator is 4p square. And now let's write down equals, that's equal to minus r over p. Minus r over p. And now this simply means x plus q over 2p all square is equal to, I'm moving minus q square over 4p square to the right hand side, and it becomes q plus q square. Let me write that here. That's equal to q square over 4p square minus r over p. When this one goes to the left hand side, it becomes plus q square over 4p square, and there is already minus r over p on the right hand side. So that means x plus q over 2p all square is equal to, now I can combine what I have. I can merge the fractions on the right hand side. The LCM is 4p square. 4p square divided by 4p square is 1 times q square. That's q square minus 4p square divided by p is 4p times r. That's 4pr. Q square minus 4pr. Now if I find the square roots of both sides, the square root of the left hand side will be x plus q over 2p equals square root of q square minus 4pr over 4p square. Q square minus 4pr over 4p square. And that means x plus q over 2p is equal to, the numerator is, we know that squares have 2 roots, so that's plus or minus root q square minus 4pr over the square root of 4p square. And now the square root of 4p square will be 2p. The square root of 4 is 2. The square root of p square is p. So that means x plus q over 2p is equal to plus or minus root q square minus 4pr all over 2p. We are leaving the numerator this way because we can't find its square root. So now we move q over 2p to the right hand side, and that means x equals minus q over 2p plus or minus root q square minus 4pr over 2p. And now we can add the fractions on the left hand side, and that means the LCM of the denominators is 2p. 2p divided by 2p is 1. 1 times minus q, that's minus q plus or minus 2p divided by 2p is 1. 1 times the whole of this will be square root q square minus 4pr. And that means, and that's x simply, which is what we are supposed to prove. And that's it simply. X equals minus q plus or minus root q square minus 4pr over 2p. That's a proof, very, very simply, using the method of completing the square. Now we go to number 2. Number 2a, Roman figure 1. Question 2a, Roman figure 1. Question 2a, Roman figure 1. If alpha and beta are the roots of the equation, 3x squared minus 5x minus 1 equals 0. 3x squared minus 5x minus 1 equals 0. Find the values of Roman figure 1 alpha q plus beta q, and Roman figure 2 alpha beta into bracket 1 over alpha squared plus 1 over beta squared. So we are doing Roman figure 1 first. From this equation, alpha plus beta is equal to minus b over a. That's minus 5 into bracket minus 5 minus b over a, which is minus 5 into bracket minus 5 all over 3, and that's equal to 5 over 3. Alpha beta is C over A, which is minus 1 over 3. C over A, which is minus 1 over 3. Now, alpha cube plus beta cube is given by the formula alpha plus beta. I think I should write it on the next line. Alpha cube plus beta cube is equal to alpha plus beta into bracket alpha square minus alpha beta plus beta square. And that simply means alpha plus beta into bracket alpha square plus beta square minus alpha beta. What I did here is just a rearrangement. I rearranged this, and now that's equal to alpha plus beta. I know that alpha square plus beta square is alpha plus beta all square minus 2 alpha beta minus another alpha beta minus alpha beta. And that simply means alpha plus beta into bracket alpha plus beta all square minus 3 alpha beta. And that simply means alpha plus beta is 5 over 3. 5 over 3 into bracket 5 over 3 square, the square of 5 over 3 minus 3 alpha beta. Alpha beta is minus 1 over 3. That's minus 3 into bracket minus 1 over 3. And that's equal to 5 over 3 into bracket. The square of 5 over 3 is 25 over 9. 25 over 9. 3 here, 1, 3 here, 1. Minus times minus 1. Minus 1 times minus 1 is plus 1. So that's 25 over 9 plus 1. And that's equal to 5 over 3 into bracket. What's 25 over 9 plus 1? That's 34 over 9. If you check that, that's what you have, 34 over 9. And that simply means 5 over 3 times 34 over 9 will be 5 times 34, that's 170 over 27. That's 170 over 27. And that's the answer very, very simply. So we go to Roman figure 2. That means alpha cube plus beta cube is equal to 170 over 27. Roman figure 2, alpha beta into bracket 1 over alpha square plus 1 over beta square. That will be equal to alpha beta. We can do it this way. Alpha beta times 1 over alpha square. That simply means alpha beta times 1 over alpha times alpha. Alpha square is alpha times alpha. This alpha cancels this alpha and we'll be left with beta over alpha. So that means beta over alpha plus, we do the same thing, alpha beta times 1 over beta square. Alpha beta times 1 over beta square. That's, let's check that. Alpha beta times 1 over beta square is beta times beta. Beta cancels beta. And you're left with alpha over, beta. Alpha times 1 alpha. And the denominator is beta. So that's alpha over beta. And that's equal to, oh no, I have to take that out. That's equal to, the LCM is alpha beta. Alpha beta divided by alpha is beta. Beta times beta, that's beta square. Plus alpha beta divided by beta is alpha. Alpha times alpha, that's alpha square. So, and that's equal to, beta square plus alpha square is the same as alpha square plus beta square, which is alpha plus beta all square minus 2 alpha beta over alpha beta, and that's equal to alpha plus beta is 5 over 3. That's equal to 5 over 3 all square minus 2 into brackets alpha beta, which is minus 1 over 3, divided by minus 1, divided by alpha beta, which is minus 1 over 3. And that simply means 25 over 9 plus 2 over 3 divided by minus 1 divided by minus 1 over 3. And that simply means, what's 25 over 9 plus 2 over 3? Let's do that. The LCM is 9. This is 25 plus 3. 9 divided by 3 is 3. 3 times 2, 6. So that's 31 over 9 divided by minus 1 over 3. Let me write it 3 and 31 properly. 31 over 9 divided by minus 1 over 3. And that's equal to 31 over 9 times 3 over minus 1. 3 here 1, 3 here 3. And the answer is simply 3 over 31 over minus 3, which is simply the same as minus 31 over 3. And that's the answer, very, very simply. So we go to question B. Question B says, form an equation whose roots are alpha minus 1 over beta and beta minus 1 over alpha. So sum of the roots of the equation, sum of roots equals alpha minus 1 over beta, alpha minus 1 over beta plus beta minus 1 over alpha plus beta minus 1 over alpha. Maybe I can make that a little better. Plus beta minus 1 over alpha. That's equal to alpha, let me open the brackets now. Alpha minus 1 over beta plus beta minus 1 over alpha. And this simply means alpha plus beta minus 1 over alpha minus 1 over beta. I can rearrange that way. And that simply means alpha plus beta minus into bracket 1 over alpha plus 1 over beta. And that means alpha plus beta. That means alpha plus beta minus into bracket, let's add this fraction, these two fractions. The LCM is alpha beta. Alpha beta divided by alpha, that's beta. Beta times 1 is beta plus alpha beta divided by beta is alpha. Alpha times 1 is alpha. And that simply means alpha plus beta minus into bracket. Beta plus alpha is simply the same as alpha plus beta over alpha beta. And that's equal to alpha plus beta is 5 over 3 minus into bracket 5 over 3, which is alpha plus beta, divided by alpha beta, which is minus 1 over 3. And that's equal to 5 over 3 minus 5 over 3 times 3 over minus 1. And that's equal to 5 over 3 minus 3 here 1, 3 here 1. And this is minus 5, which simply means 5 over 3. Of course, you know that 5 divided by minus 1 is minus 5. So that's 5 over 3 plus 5. And that simply means 5 over 3 plus 5. That, let's see, that's 20 over 3. And that's the answer, very, very simply. So we go, no, okay, that's not the answer. This is the sum of the roots. So sum of roots equals 20 over 3. Now we go to product of roots. They said we should find the equation. We should form an equation whose roots are 1 over alpha minus 1 over beta and beta minus 1 over alpha. So product of roots is equal to alpha minus 1 over beta. You have to be careful so that you don't stop where you're not supposed to stop when you haven't got the final answer. Alpha minus 1 over beta times beta minus 1 over alpha, and that's equal to alpha beta minus, we are doing alpha times the whole of this, and then we do minus 1 over beta times the whole of this. We are opening the brackets. Alpha times beta, alpha times minus 1 over alpha. We are saying alpha times minus 1 over alpha. Alpha cancels alpha, and the answer is minus 1. So that's alpha beta minus 1. Now minus 1 over beta times beta. Let's check that. Minus 1 over beta times beta. Beta cancels beta, and that's minus 1. And now minus 1 over beta times minus 1 over alpha. That's plus 1 over alpha beta. You can check that. Minus 1 over beta times minus 1 over alpha. That's plus 1 over alpha beta. Now, let's continue from there. You have to be very, very careful and make sure that you're not making mistakes. And that simply means alpha beta plus, let me rearrange this way, alpha beta plus 1 over alpha beta minus 2. Alpha beta plus 1 over alpha beta minus 2. Minus 1 is minus 2. And that simply means alpha beta is minus 1 over 3 plus 1 divided by minus 1 over 3 minus 2. And that simply means minus 1 over 3 plus 1 divided by minus 1 over 3 is going to be 1 times 3 over minus 1 plus 1 times 3 over minus 1 minus 2. And that's equal to minus 1 over 3 plus, okay, that's minus 1 over 3. 3 over 1 times 3 over minus 1. 1 times 3 over minus 1 is minus 3. And when you open the bracket here, you have minus 3. So that's 1 over 3 minus 3 minus 2. And that simply means that's minus 1 over 3 minus 3 minus 2. And that simply means minus 1 over 3 minus 5. So let's do that. The LCM is 3. 3 in 3 is 1 times minus 1 minus 1 minus 1 in 3. 3 divided by 1 is 3 times 5, 15. And that's minus 16 over 3. Minus 16 over 3. So the product of the roots is minus 16 over 3. And that therefore means that the equation whose roots are x minus 1 over beta and beta minus 1 over, that therefore means that the equation whose roots are alpha minus 1 over beta and beta minus 1 over alpha is given by x squared minus sum of roots. The sum of the roots is 20 over 3. X squared minus sum of roots, which is 20 over 3 times x. X squared minus sum of roots times x plus product of roots. So that's x squared minus the sum of roots, which is 20 over 3 times x plus product of roots, which is minus 16 over 3 equals 0. Equals 0. I want to put everything on a single line. Equals 0. Equals 0. So the equation whose roots are alpha minus 1 over beta and beta minus 1 over alpha is given by the formula. That equation is x squared minus sum of roots times x plus product of roots. So that will be x squared minus 20 over 3 times x plus minus 16 over 3 equals 0, which simply means x squared minus 20 over 3x minus 16 over 3 equals 0. And now if you multiplying through by multiplying through by multiplying through by 3 to clear the fractions. We have 3x squared minus 20x minus 16. 3x squared minus 20x minus 16 equals 0. And that's the equation very, very simply. And that's the end of number. That's the end of number. Okay. Okay. That's 2b. Now we go to question 2c. Let's go to that quickly. Question 2c. Question 2c. Question 2c. The sum of the first n terms of a sequence is given by Sn equals 5n squared over 2 plus 5n over 2. Write down the first 4 terms of the sequence and find an expression for the nth term. When the sum of n terms of a sequence is given, the formula for the nth term is given by Sn minus Sn minus 1. And that will be equal to 5n squared over 2 plus 5n over 2 minus, let me write that here, Sn minus 1 is what you get when you put n minus 1 wherever you see n in the formula for Sn. So Sn minus 1 will now be 5 into bracket n minus 1 square over 2 plus 5 into bracket n minus 1 over 2. Let me put this kind of bracket here. And that's equal to, that will be equal to, if I add 5n square over 2 to 5n over 2, I'm going to get 5n square. If we add these two fractions, we'll get 5n square plus 5n over 2, since the LCM is 2, minus, here I'm adding these two fractions too. Their denominators are the same. So I'm going to have minus into bracket 5 times n minus 1 square plus 5 times n minus 1 all over 2. All over 2. And we proceed. That simply means 5n square plus 5n over 2 minus, let me open the brackets here, 5, okay, I'm not even opening the brackets yet. Let's square n minus 1. The square of n minus 1, if you work it out, is the same as n square minus 2n plus 1 plus, we can open the brackets here, 5 into bracket n minus 1 is the same as 5n minus 5. And the whole of that all over 2. The whole of that all over 2. And that's equal to 5n square plus 5n over 2 minus, we have the brackets, we can open the brackets here, and that will be 5n square minus 10n plus 5 plus 5n plus 5n minus 5 all over 2. All over 2. And that simply means here 5 minus 5 is 0. Minus 10n plus 5n is minus 5n. So I'm going to have, that will be equal to 5n square plus 5n over 2 minus 5n square minus 10n plus 5n, that's minus 5n. 5n square minus 5n over 2. And now the next line will be 5, that will be equal to 5n square plus 5n over 2 minus, this is what it looks like, minus, let's write it this way, into bracket 5n square minus 5n over 2. So now we can find the LCM. The LCM is 2, and the numerator remains 2 divided by 2 is 1. 1 times the whole of this will be 5n square plus 5n. Now 2 divided by 2 is 1. 1 times the whole of this will be what it is, but don't forget the bracket. minus 5n square minus 5n. You put all of that in brackets, and that will be equal to 5n square plus 5n. You open the brackets here, minus 5n square plus minus times minus 5n will be plus 5n all over 2. And now what do we have? 5n square minus 5n square is 0, and that will be equal to 5n plus 5n, that's 10n over 2, and that therefore means that Tn is equal to 5n, and this is the expression for the nth term of the sequence. Now we can find the first 4 terms. T1 will be 5 times 1, which is 5. T2 will be 5 times 2, which is equal to 10. T3 will be 5 times 3, which is equal to 15. And T4 will be equal to 5 times 4, which is equal to 20. And that is it very, very simply. That's it very, very simply. Go to number 3. Number 3A, question 3A. Question 3A. Let E, if E, the universal set E with elements 1, 2, 3, 4 up to 10. The universal set E with elements 1 to 10. The universal set E with elements 1 to 10. With elements 1 to, if E, the universal set E has elements 1 to 10, and set A has elements which are, the elements of set A are odd numbers up to 9. Odd numbers up to 9. And the elements of set B are numbers less than 7. Numbers less than 7. Numbers less than 7. Write out the members of the following sets. Roman figure 1. We want to write out the members of the set A complement. First of all, to write out the members of the set A complement, I have to write out the members of the set A first. Or let me even start from the universal set. The universal set, the elements of the universal set are 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. These are the elements of the universal set. So the elements of the set A, which are odd numbers up to 9, will be 1. Odd numbers up to 9, that's 1, 3, 5, 7, and 9. 1, 3, 5, 7, 9. That means A complement, the elements of the set A complement will be, 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Those are the elements that are in the universal set, but not in set A. Now, Roman figure 2. Write out the elements of the set B complement. Let's write out the elements of the set B first. Set B is a set of numbers less than 7. Set of numbers less than 7. That will be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So B complement, the elements of the set B complement will therefore be, that's 7, 8, 9, 10. 7, 8, 9, 10. Now, Roman figure 3, the elements of the set A union B. Roman figure 3, the elements of the set A union B That's the combination of the set A and the set B. Now, this is a trick for writing out the elements of the union of two sets. Write all of the elements of the set A first. Let's write that 1, 3, 5, 7, 9. Now you check the set B and write the things that are in B that you have not already written in A. So let's check that. B, this is set B. We have written 1 already. We have written 1. We've not written 2. So you put the 2 here. We've written 3 already. We've not written 4. So you put 4. We've written 5 already. We've not written 6. So you put 6. So the elements of the set A union B are 1, 3, 5, 7, 9, 4, and 6. Arrangement doesn't matter. It doesn't matter whether you arrange in the right order or not. So Roman figure 4, the elements of a set A intersection B will be the elements that are common to both A and B. Let's see that. This is set A and this is set B. Let's see the things that are common to them. 1 is in A and 1 is also in B. So we write that 1. 2 is in A. No, 3 is in A, but 3 is not in B. No, 3 is in A and 3 is also in B. So we write that 3. What else? 5 is in A and 5 is also in B. That's 1, 3, 5. We write that. 7 is in A, but 7 is not in B. We don't write that. 9 is in A, but 9 is not in B. We don't write that. So we check again. 1 is in A, 1 is also in B. 3 is in A, 3 is also in B. 5 is in A, 5 is also in B. So the elements of a set A intersection B are 1, 3, 5. 1, 3, 5. So that's the set A union. That's the set A intersection B. Now let's go to the next Roman figure 5. Roman figure 5. The elements of a set A complement intersection B complement. So those are elements that are common to the complement of A and the complement of B. So how do we do that? Let's go. Elements that are common to the complement of A and the complement of B. So let's see that 2 is in A, but 2 is in A complement, but it's not in B complement. We don't write that. 4 is in A complement, but it's not in B complement. We don't write that. 6 is in A complement, but it's not in B complement. We don't write that. 8 is in A complement, and it's also in B complement. So we write that. 8. Let's check. Is there another one? 10 is in A complement, and it's also in B complement. So the elements of a set A complement intersection B complement are 8 and 10. The elements of a set A complement intersection B complement are 8 and 10. So now we go to, okay, that's the end of question 3A. We now go to 3B. 3B, Roman figure 1. If X and Y are members of a set E, which is the same universal set with elements 1 to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. If X and Y are subset of this set, are members of this set, list the members of the following subsets of E. Roman figure 1, that's what we are doing. X, list the members of a set X, which has elements X such that X minus 2 is less than or equal to 2. Elements X such that X minus 2 is less than or equal to 2. How do we do that? First of all, we solve this inequality. X minus 2 is less than or equal to 2. X minus 2 is less than or equal to 2. That means X is less than or equal to 2 plus 2. If you move this minus 2 to the right hand side, it becomes plus 2. And that means X is less than or equal to 4. So that therefore means that the elements of the set X are 1, 2, 3, and 4, because it says X is less than or equal to 4. And those are the elements of the set X. Roman figure 2 says the element of the set Y, the element of the set Y and the set Y has elements Y such that 3Y minus 2 is greater than or equal to 19. Now, first of all, we solve this inequality. We solve inequality 3y minus 2 greater than or equal to 19. 3y minus 2 greater than or equal to 19. And that means 3y is greater than or equal to 19 plus 2. Move minus 2 to the right-hand side, and it becomes plus 2, which means 3y is greater than or equal to 21. And when you divide through by 3, you have y is greater than or equal to 7. So that means the elements of the set y is greater than or equal to 7, and the universal set has elements 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means the elements of the set y will be 7, 8, 9, and 10. Those are the elements of the set y. And Roman figure 3 says, hence find the elements of a set, find the elements of the complement of the union of x and y. Before we can find this, we need to find x union y first. The set x union y is a combination of the set x and y. Write all the elements of x first, 1, 2, 3, 4. That's 1, 2, 3, 4. And now you write the elements of y without writing what is already in x. So 7 is in y. Have we already written it? No, we've not already written it, so we write that. 8 is in x, is in y. We've not already written it. We write it. 9 is in y. We've not written it already. Let me write the 9 properly. And 10 is in y. We also haven't written it already. So that means the set x union y has elements 1, 2, 3, 4, 1, 2, 3, 4, 7, 8, 9, and 7, 8, 9, and 10. And that therefore means that the complement of the union of x and y will have elements. What's that? 1, 2, 3, 4, 7, 8, 9, 10. We don't have 5. We don't have 6. 1, 2, 3, 4. Yes, the elements of the complement of x union y are 5 and 6. 5 and 6. And that is it very, very simply. That's it very, very, very simply.